good day. I am Mark Angelo Galvez from Bachelor of Science in Civil Engineering Section 1E. And for our topic for today is all about the conservation of mechanical energy. So first, we just need to know what conservation of mechanical energy is. So, if only conservative forces do work, the total mechanical energy of a system neither increases nor decreases in any process. It stays constant, it is conserved. The total mechanical energy, E, is the sum of the kinetic energy and the potential energies at any moment. So we have a formula of E equals kinetic energy plus potential energy, E equals E. So, let's move to the example number 1. Example number 1. A man of a mass M drops from a board 10.0 meter above the water surface. Neglects its resistance or air resistance. A. Use conservation of mechanical energy to find his speed 5.00 meter above the water's surface. Letter B. Find his speed at he hits the water. So, let's draw. Ano ba ito magdadaan? As we can see in the figure, the system consists of only the diver and his preference point when he is in the ground. So, 5.00 meter. So, as a diver falls, only the force of gravity acts on him. Again, we neglect the air resistance so that mechanical energy of the system is conserved. And we use the conservation energy for both parts. So, let's move for letter A. E sub I equals E sub F, or E initial equals E final. So, kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. By substituting the equations, we have here 1/2 mv initial plus mgy initial equals 1/2 mv final squared plus mgy final. In this, maka-cancel natin yung in this, we just need to cancel this. We can now cancel the mass and our initial velocity is 0. Also because it is start from the rest which is 0. So, ang natira sa equation natin is we have gy initial equals 1/2 v final or velocity final plus gy final. Final velocity which is yun yung hinahanap natin. We derived the equation to solve for the final velocity. So we have here 2 the quantity of gy initial minus gy final. It is equal to 1/2 final velocity squared quantity squared. Multiply both side by 2 para ma-cancel si 2. And we factor out g. So, cancel natin si 2. We have now 2g quantity of initial minus y final equals final velocity squared. Now, take the square root both side para makancel yung squared ng final velocity. So, square root of 2g, quantity of y initial minus y final, it is equal to square root of final velocity squared. So, makakancel na natin ngayon si square root at si squared. Ang matitira na lang sa atin ngayon is final velocity equals to square root of 2g, quantity of yi, minus y final. Substitute na natin yung given value. So, solving for the final velocity is at 5.00 meter. So, final velocity equals square root of 2, quantity of 9.81 meter per second squared. Sa loob yung squared times 10 meter minus 5 meter. So our final velocity is equal to 9.9 meter per second. Ito na ngayon yung final velocity niya or yung velocity niya at a point of 5.00 meter. So let's move to letter B. So now, let's move for the letter B. Our potential energy is 0, so we have 1/2 mv initial squared plus mg y initial equals 1/2 mv final squared plus mg y final. So, makakancel natin to, magiging 0 na lang. So, again, our final position is 0 and our initial velocity is 0. We can now cancel the mass. Yun nga, kinancel natin yung mass. So, we have gy initial equals 1/2 final velocity. And that final velocity is at the reference we are now in water. So, for solving the final velocity squared, we just need to cross multiply. So, cross multiply. Ang natira na lang ngayon ay 2gy initial equals final velocity squared. Take the square root of both sides para makancel natin si squared ni final velocity. So, square root of 2gy initial equals square root of final velocity squared. Cancel natin si squared at si square root. We have now final velocity equals 14 meter per second. If we can notice that the speed halfway down is not the halfway to the final speed. Another interesting point here that is the final answer doesn't depend on the mass. That is the reality of the consequence of neglecting the change in kinetic energy of Earth, which is valid when the mass of the object taking about that diver is smaller or is much smaller than the mass of the Earth. In reality, Earth also falls towards the diver using the final speed. Matter is so minimal it could never be measured. So this is the example number 1.